called out to this job because the power had cut to the counter here where the coffee machine is, and then also the sockets underneath there where the fridges are plugged in. So the consumer unit's up there, which has been changed now. We'll have a look at that in a minute. So when I came out, I found that the problem was in the kitchen. So the issue was someone had been in and installed a load of sockets on a radial circuit and spurred off a ring circuit which already was not in a good state. So they had this 3 kilowatt oven plugged in to a cooker socket that had an actual socket outlet on it as well as the isolator, and then they had these rings on as well. So when they had this on and they had the hob on together, this was running at like 50 amps, so it was only on a 32 amp circuit. So that was tripping that out, so they couldn't use that. So what they did is they plugged the oven then into these row of sockets that somebody had put on for them, which wasn't again right, which then blew these two. So, and this socket circuit was one socket circuit for the entire building. So it's doing a commercial kitchen, it's doing a commercial counter with a high rated coffee machine, high kilowatt coffee machine, fridges. At the back there you can see that it's doing chest freezers, more freezers, it's doing a boiler, then it's doing hand dryers as well. So this one socket circuit in here is doing absolutely everything, so it was overloaded very easily, and that's where the problems were, and they were tripping out. So these are some of the machines that they plugged into them as well. So they've got like a, what's this, 3.6 kilowatt, maybe 1800 kilowatt, 1.8 kilowatt, sorry, and then a 3.6 kilowatt plugged into a circuit that was spurred off, I think, this hand dryer. So this power supply came in here from the boiler side down to this FCU for the hand dryer, and then it went down there through the wall. Then it supplied an oven, a 3 kilowatt oven. Then it was supplying panini maker, microwave, toaster, and then anything else that they had plugged in it as well. So that was all on a 2.5 spurred off this circuit, off a ring that was already in a bad way. So they got someone in. I got the power back on that day and disconnected as much as I could to make it so it was safe as possible, and has told them just to use temporarily only 2 rings on the hob, and we plugged the oven into a different socket circuit. In the meantime, I suggested that they have a condition report done. The consumer unit needed upgrading because it was a 3036 rewirable fuses, and then all this work that they paid some other guy who was apparently an electrician, but he'd done a terrible job, he'd not signed any of it off, so he was probably just a bit of a DIY bloke, and then that all needs changing. So notified the landlady that the building's really not fit for purpose because it can't run all this equipment. So she's quickly had the consumer unit changed. I think she's notified a letting agent to manage it for her because it's been neglected for about 40 years, I think, this building. No condition reports have been done the entire time this place has been rented out because there's no paperwork, no proof. So what they did is they got on it quick, changed the consumer unit, gave an installation certificate. This guy is the second electrician that's been in here, and he's done this job here. So all this, we just put pictures on, I've took some pictures, but all this trunking was just like flapping off the wall there. You've got all this cable, it's not been tidied up. It should be like a rubber flexible cable to this, this movable appliance. And then he's put these sockets back, but he's spurred off a socket circuit. There's a little blank plate at the back of there, I don't know if you can see it. So he's just tapped off that with a 4mm and come here, and then he's just done spur to supply the microwave, the toaster, and then all the panini machines are on here. Dishwasher as well, this is plugged in, and this is like a 3 kilowatt dishwasher too. So really all these things should have their own circuits, or at least it should be split into a few circuits, because we've got all this really high current using equipment in here, and it was all been running on this one ring, which is just, it's all started to fail now, and then it become dangerous. So luckily for the landlady, or the landlord, nobody got injured, because if someone had got injured at the time when I got called out and this was at its most dangerous, and one of the staff had been electrocuted, or there'd been an appliance, something had caught on fire, and there was people injured in the shop, or again staff, that would have been a major lawsuit with the landlady or landlord, because they have not kept up the maintenance of the electrical maintenance of the building. So luckily for them, nothing happened, and then they've done the absolute bare minimum of work just to get it a pass certificate, and this is now what these ladies are left with. So we're coming in, ripping everything back out again and doing it properly, and trying to separate this kitchen from the rest of the building, so this is on its own chunky supply coming in with its own consumer unit. But so what this guy done here, like technically it was covered, because he'd spurred off a ring with a 4mm, and then that made that a radial, so that cable was capable of carrying 32 amps, and the breaker would trip if this was overloaded if it was any more than 32 amps flowing through that cable could have handled that, but it's still not. It's a very, very bad job what's been done
behind the radiator.
Yeah, like this cable was just sticking out of the trunking there. There was no lid on the trunking. This is just like, that's how it's just crap. And then this goes behind the radiator, which, that decreases the rating of the cable as well, being near a heat source. And it just goes underneath there, trails along the floor. And this is the guy that's been in, who was supposed to be the professional electrician that signed this off. So we'll have a look at his consumer unit in a minute, see what's been done there. And then, so what we're planning on doing in here to make this safe is we are putting, you can see there's a consumer unit been mounted already. We're going to run an armoured cable from the meter cabinet outside, along the outside of the building, and supply this board off the actual tails at the main cutout. Remove the entire kitchen off the existing circuit, and separate the shop from the kitchen. So in here we've got the biggest amount of current being used, so this will have its own 80 amp supply to this board, and then that can tick along using the bare minimum of whatever it needs to. And then in here we're going to run some steel trunking around both sides and resupply all the appliances. So we're going to come down here, we're going to have supply for toaster, supply for dishwasher, socket, supply for panini makers, isolator for a 32 amp circuit for the hob, and then a 20 amp circuit just for the oven. So we've separated all these appliances into individual circuits, so there's plenty of the cables and that can take plenty of load that we've put in, more than capable of dealing with these large appliances. The fridges as well, we're going to put some sockets at the top, because at the minute this is how everything's plugged in. So there's one socket behind this freezer here, and everything's running on extension leads. So it's just very, very badly organised, not suitable really. I say this is technically, it's a commercial building, even though it's only a small shop, it's still a commercial building. So it's not fit. It's not fit for purpose to be a kitchen really. I don't think. It's more like a set of offices or something that could probably deal with being that. So that's what we're planning on doing anyway. I'm going to go and have a look at the consumer unit.
So yeah, you can see that the aircon circuit is actually off at the moment, because when I came to have a look at the job and just have a look, see, determine what was on each circuit, turn the aircon on, and it was tripping out straight away. So that leads me to suggest that perhaps the installation wasn't properly tested at the time of this board change. You can see there on the tails in that Henley block there's basic insulation on show, which there obviously shouldn't be. Should be double insulated. So it's not particularly well fixed to the wall,
And it's a budget range consumer unit. So it's RCBOs which are great. You want RCBOs absolutely. So this is definitely, you know, it's better than most boards without a doubt, but it's still a Screwfix special or budget consumer unit. This, so just, you know, we can pick one of these up, but extremely cheap. There's no spare ways. Well, he's got a spare there actually, tell a lie, but normally we'll put these in and we'll leave, you know, 4 spare ways in these or whatever for any future expansion. And here it's just, you know, it's going to be, it's busy. It's a busy board. There's only one available spare way. To say this is a brand new installation, you know, just expect it to be better than this, really.
Oh, so they're type AC RCDs, and you know, we tend to fit type A as standard now, which take care of type AC faults, AC fault currents, and also pulse DC fault currents for anything that's got electronics in, which, you know, aside from the resistive loads like the I suppose the hobs and the cookers and what have you, the panini toasters, there's still plenty of gear in the kitchen and front of house that has electronics in it. And I think in the Second Amendment, which is coming out next year, the advice will be that type A is the go-to standard, unless you can sort of guarantee that it's only going to be a resistive load that's giving AC fault currents.
The electrician that the estate agent got in here came in and installed this circuit here, this 4mm, and added it onto some sockets for the panini makers and for the dishwasher and for the oven as well. So what he's done is he's run that cable in, he's gone behind the radiator, and then he's, as you can see down there, we've just cut the back of the kitchen out. That socket above is supplied from, is already spurred off. I'm assuming what's a ring behind that blank plate, and then he has run his 4mm up to that as well to spur to all these, and then it's spurred off to this FCU for the fan as well. So this guy is a legit electrician, and he signed a certificate off. Apparently he's an NICEIC registered bloke, but even if that will carry the load of that 4mm, that still isn't acceptable. We wouldn't sign that off and leave the building with it in this condition. And then also, yeah, as it's supplying so much big current using equipment, if you just did it to a few sockets and it was just doing a few smaller items like a microwave and a toaster, it's not as bad. But because it's supplying a huge commercial oven, a commercial dishwasher, commercial panini makers, the fact that that guy has done that and has signed that off as acceptable, if he signed it off or not, we don't know. I've not looked at the cert yet, but I think he's given an installation cert for the consumer unit, but I don't think he's given any installation certs for any of this work he's done. In our experience, when you've got management companies and estate agents looking after people's property on their behalf, in our experience, the estate agents that we've seen and the houses we've been to that they've been managing have been pretty bad. So obviously that's not for all estate agents. I'm sure some are doing a good job, but in this case and all the other cases that we've seen, this is the kind of standard of work that we're getting. And whether the estate agents know that or not, I don't know, but the homeowners or business owners definitely don't know that. And they are trusting someone to come in, be sent in and do the job and keep it all above board and legal for because it's their neck on the line at the end of the day. It's the actual landlord, landlady's neck that is on the line. So yeah, just be aware of that. It'd be good to do some checks of your own, basically on your own property or business, if you've got another company managing it for you and sending their own tradesmen in, whatever. Because like I say, this is what you've seen here is what you're getting basically. Right, I just wanted to point out why what's been done isn't right. So in our guidance here, our current BS 7671, our current regulations, it shows on here, ring and radial final circuit arrangements. Yeah, so it just tells you what you're allowed to how many times you're allowed to spur off rings, what case of cable size you're allowed to use from FCUs, and then also what the maximum load is for fixed equipment that you're going to attach to our appliances. So connecting cookers, ovens, hobs with a rated power exceeding 2 kilowatt on their own dedicated radial circuit. So every one of these appliances in here, apart from that microwave, I mean the new toaster as well, it's not in here, but that's 1.4 kilowatt. So literally every appliance in here, according to this, should be on its own circuit. So doing a spur off a ring circuit to 5 sockets, and then doing a 3 kilowatt oven, a 3 kilowatt panini, a 2.6 kilowatt dishwasher, a 1.4 kilowatt microwave, and another 1.5 kilowatt panini grill, as well, is ridiculous. Basically. So basically every one of these, it seems overkill, but as you can see here now, we've got what we've done here now. Everything's into trunking, which is easily cleanable. They obviously don't want to make any mess, so we're not chasing walls out and stuff like that. And we've got bundles of circuits to get in as well. So I think we've done so far, is it 11 or 12? So this is only a small kitchen anyway. This is a commercial kitchen, but it isn't a big commercial kitchen. This is as small as a commercial kitchen gets, really. So here we've got an oven circuit, hob circuit, and then we've got that's on its own circuit for the oven. Own circuit, own circuit, own circuit. All these sockets are on their own circuit because we're plugging a 2.8 kilowatt toaster in. Again, 2.8 kilowatt dishwasher in. So every appliance here, due to the rating of it, needs its own radial circuit. Again, that seems overkill, but it absolutely isn't. If we wired them 3 sockets on one circuit, it would nearly be overloaded with what they plug into it. And that's just 3 sockets on one circuit. So in here we've got everything split into as many circuits as possible. We've got a circuit here for another potential dishwasher under here. And then we've got a circuit there which is these use hardly anything. But there we're picking up a fridge freezer and then this fridge unit here. But the wattage of them is extremely low, so they're not an issue. But just explaining why the way it was left wasn't correct. We're just doing, you want to have a look in there? We're just doing the R1, R2, R2s of all the circuits that we've put in. So I'm just doing the test now across live and earth in the back of the isolator and getting our readings.
So what we do is we temporarily link out live and the CPC in the consumer unit. We then go to the furthest accessory on the circuit, which in this case is the hob, and there only is one accessory, and then we can take a resistance measurement between line and CPC. So that is the R1, R2. We then add that onto the external fault loop impedance, and that gives us a value called the ZS, and that has to be below a certain value to make sure that the protected device in the consumer unit trips in the right time. And we'll check that all this trunking that we've installed is all earthed, which by definition it should be, because you can see that Paul has bonded the back box to the plate, which is connected to the CPC, and it's all bushed in. It's got these couplers, and it's all a continuous piece of metal, which is then bushed into the board up there as well. So as well as the CPC, all the metalwork is connected to earth as well.
So as these are all individual radial circuits, you'd expect the readings to be very close to each other, or pretty much bang on, as exactly the same, because the distance between there and there is the only difference. There is a slight extra, for 300 mil. So the readings on here, if you look at the R1, R2 readings, they're all 0.06, 0.06, 0.06. So they're all pretty much the same length. Some of them obviously 0.05, 0.04, but all these readings are absolutely bang on what we'd expect them to be.
Okay, so now we're doing our RCD tests. The RCD being the part of the protective device that is really sensitive to any fault to earth, any current flowing to earth. So any exposed metal work on any of the sockets, anything like that, there's any more than 30 milliamps flowing, these devices will trip. They are type A RCDs. So we've selected the rated current on the fluke tester. We've put it on type A mode, and we're doing an automatic test which runs through several different tests. So we'll just have a look at that now. So we've just done all the RCD disconnection times. So the meter runs through an automatic sequence of tests, one at half times the rated current, one at its rated current at 30 milliamps, and then one at 5 times its rated current, and that's the value that we measure down, that we write down. And this has to be less than 40 milliseconds, and you can see here that this is one of the reasons we like using Hager, because all of these values are well under that and within about 1 to 2 milliseconds of each other. We talked about the R1, R2 measurements before. We've taken we've measured in most cases the maximum ZS, so it's just a separate test that we do where we can plug into the sockets, and it just measures the entire earth fault loop impedance, and it's got to be, this value has got to be lower than the maximum permitted value there. So you can see 2.19 ohms versus what we measured 0.23, it's well below that. So those values that we've measured for our new circuits are all massively under what they could potentially be, so disconnection is going to happen in the right time. Other tests that we've done, insulation resistance, they're only short circuits, but nevertheless we zap it with 500 volts to make sure that the insulation is intact after installation. So you can see here that, yeah, in fact, they're all greater than 500 million ohms, which is well above what it needs to be to pass the test.
We took a continuity reading of the ring circuit in the kitchen as we removed the old spurs off there. So we thought we'd check that that's okay as well, which this guy's on his certificate said he's checked and that it's okay. So we've just took one of the plates off in there that had some Wagos on it, that he Wagoed the 4mm out to the spurs. So the readings in there were 0.6, 0, live and neutral, and then open circuit for the earth. So the ring actually isn't continuous on the earth. So we've just come to the board now and doing a ring check here, making sure that there's not rings within rings and readings are actually still the same. So we've got a slight difference in test reading here, which is on the neutral, it's 0.65, whereas it was 0.60 in there. So that's the only difference we've got here, and it's still showing that we've got an open ring on the earth as well. So that's an issue that needs sorting out. But on the installation certificate, it said we've actually got legit readings saying that the rings are okay. So that's something that needs looking back at as well. So originally we pulled up that there was problems in the building. Someone else has been out, and what we said is it needs a condition report because there's not been any maintenance or any condition reports on this for 40 years plus, and it's a commercial building as well, so it should be a restaurant, comes under restaurant, so it should be tested every 5 years. So this has gone 40 years minimum without being tested or any work being done. So we pulled that up and suggested that it needed a condition report. The estate agent has got somebody else in to do the work, but they've not actually done the condition report. Now this is where there's a misunderstanding, I think, of what people actually require and the work that's being done. So he's come in, changed the consumer unit, and he's given him an installation certificate for the job he's done. Now, the ladies here said that when he was here, it was quite quick, and there wasn't like a light that you knew you'd take a light down to check any wiring or connections or anything like that. So we know that it wasn't a thorough test. So he's given an installation certificate for the consumer unit change, and he's done some test readings, some very basic test readings, but he's not done thorough checks on the building. And we could see that on the certificate that because we've had a quick look at what he's given. So there's some things that has given us a bit of a suspicion that there was problems and it hasn't been tested properly. So we're just doing a couple of things, double checks while we're here as well. Even though this is nothing to do with what we're doing, we're just double checking it while we're here, and we're going to put it on the report. And if we're doing an installation certificate as well, we do test the building thoroughly afterwards, and any issues that we do. So basically we do a condition report when we do an installation certificate if we were doing a consumer unit change, for example. But most people will do the basic bit of testing and not cover all the areas that need doing now. So this building basically hasn't had a condition report still. So there's been the work that we pulled up originally after the call out. A consumer unit has been changed. An installation certificate has been given for the consumer unit change. We've been in here, removed some work that another electrician has done, and put a brand new supply into the kitchen. So we're going to give an installation certificate for the kitchen, but still all these people have been here and all this work's done, and that hasn't actually been a condition report. So a legit EICR, there hasn't actually been one of them given. So yeah, we'll just do a few bits now which we thought were suspicious. Another thing that we would have pointed out is that all these twin and earth cables on the outside of the building are all the incorrect cable. They should be UV rated for starters. So that stuff is going to be very brittle because it's been outside and getting exposed to UV. Also, there's not a clip. That 6mm cable there, that comes from the consumer unit up over the top, and it just swings down off that drain pipe. No clips in it. Then it goes through the wall down and feeds the coffee machine on the other side in front of the house. So we would have mentioned that on the certificate or a condition report as well. Cables not supported properly, incorrect cables used outside. So what we've done here is we've put some tail blocks inside here. Off the meter supply, we've just jointed the consumer unit in the coffee shop up there. Instead of them going straight into the meter, they go into our blocks now, and then we put a new supply to the meter and split them in there. So it goes to an isolator here with an 80 amp cartridge fuse in it, and then we've got some 16mm tails there that go up and then into this adaptable box and joint onto our armoured cable. We would have liked to have put that armoured cable straight into this box, but there's not enough room to do that. So if we've got to put gland an armoured cable off in here straight into an isolator, usually the metal isolators that take a gland are about this big, roughly. So there's actually not enough room in here to be able to gland something into a metal enclosure and have a switched fuse. So this is what we've had to do because we've not got space to fit that in here. So that's why we've got an adaptable box here. And then that's clipped all the way along. We'll have to go around these pipes, which is a bit of a pain, but there's nothing we could do about that. And then it flips along and then goes straight through the wall, and then it's glanded into our consumer unit on the other side of this wall in the kitchen.
Okay, so we've just got the clamp meter, ammeter around the tail, the live tail that's going to the kitchen. We've got everything on full whack just to, check the full load. Obviously you can apply diversity to certain bits of equipment in the kitchen, but we're just doing a sort of like a worst case scenario if they had all the toasters, microwaves, ovens, etc. on full. So we've got an 80 amp supply and we're running at 77 amps, but it's never, practically it's never going to be running at that sort of level. The oven is not going to be on full whack. All 4 rings are not going to be on full whack the whole time. But it's just interesting that you can see there, yeah,
76.
You can see there that there's the provision for it. If they did have everything on full, the wiring system that we've installed is more than capable of carrying that, and it's never going to reach that sort of maximum. load, I would have thought. So, yeah. So you can see here, just further to what we were talking about before, we've got all 4 rings on full blast. We've got the oven on 250 degrees. We've got the grill, the toaster, the panini maker. So let's just do another quick experiment. We'll turn it down to like a usable level. About what we'll set it up for a situation that might, happen in the kitchen, and we'll go and take up the measurement and see what it says. There you go. You can see now that we're down at about 40 amps. So we've just knocked, I think, a ring off or 2 rings off. The oven's still on. The toaster's on. Turned the grill off. The panini maker is, just put that down to a usable temperature as well. So yeah, that's a more realistic idea of what's going to be in use consistently. So we use about half the capacity of the cable there.